with dependent samples. Each observation in one sample has a matched observation in the other sample. Those type of observations are called matched pairs. Here are benefits of using dependent samples. Source of potential bias are controlled, so we can make a more accurate comparison. Using matched pairs keeps many other factors fixed that could affect the analysis. Very often, using dependent samples benefits in smaller standard errors. Recall the calculation of a confidence interval. When the standard error is smaller, the confidence interval is narrower, so that we have a smaller range of the possible value the population parameter may fall in. And this is a good property that all statisticians want. When we compare means with matched pairs, we should use pair difference. For each matched pair, construct a new variable consisting of a different score. We denote D for the difference. The sample mean of the different scores equals the difference between the means for the samples, denoted as X bar underscore D. The difference between the population means, mu1 minus mu2, is denoted by mu-d and represents the population mean of the different scores. We use the X bar D to estimate mu-d. Here is the formula for confidence interval calculation. X bar D plus or minus the t-critical value found by using the table B from textbook, times the SD, which is the standard deviation over the differences, divided by the square root of sample size. To set up hypothesis test for matched pairs, the claim should be, is there evidence that the means are different between the two populations? The alternative hypothesis should be mu1 doesn't equal mu2. Equivalently, will be mu1 minus mu2 doesn't equal 0, or mu-d doesn't equal 0. The null hypothesis will be mu-d equals 0. The test statistic will be calculated as the X bar D minus n divided by the ratio of standard deviation and the square root of sample size. Since this test uses the different scores for the pairs of observations, it is called a paired t-test. Just like what we did for other hypothesis tests, we also need to check assumptions for paired t-test. The sample of different scores is a random sample. The keyword is random, from a population of such different scores. The different scores have a population distribution that is approximately normal. This is mainly important for small samples, or in other words, sample size less than 30, and for one-sided inferences. Here is how we can interpret confidence intervals. Remember that we are using confidence interval to estimate this value. The situation 1. Both values in the confidence interval are positive. Hence, we have the conclusion that the mu1 is larger than mu2. So you can write down like we are either 99% or 95% or 90% confidence that the population mean for group A is at least the lower bound and at the most upper bound units greater than the population mean for group group B. Situation 2. Both values in the confidence interval are negative. Signs, we can claim that the mu1 is less than mu2. So we can say we're 99 or 95 or 90% confidence that the population mean for group B is at least the upper bound and at most the lower bound units greater than the population mean for group A. Pay attention that when you write down the upper bound and the lower bound, you do not include the negative sign. We do not include the negative sign because the mu2, which represents the population mean for group B, is larger than mu1, which is the population mean represents for group A. Last situation. The lower bound is negative and the upper bound is positive. So the interval contains 0. So it is possible that there is no difference between the means for the populations. So we are 99 or 95 or 90% confidence that it is unclear whether group A or group B has the greater population mean. If group A has the greater population mean, it is by the at most the upper bound units. If group B has the greater population mean, it is by at most the lower bound units. Here is how we can interpret hypothesis test. It is in the same form as other hypothesis tests we have done. If the p-value is less than the significance level, then we say with the p-value equals to some number, we have sufficient evidence that the alternative hypothesis is true. If the p-value is larger than or equal to the significance level, we say with the p-value equals to some number, we have insufficient evidence that the alternative hypothesis is true. Here is the StatQuant commands you will need to do your homework, including your lab assignments.